Good day, good day, good day, good day, good day. Now let's look at the convergence and the sum to infinity. It's quite crucial and important to understand a few things. That when we're looking at the sum to infinity, the equation will always be sum to infinity is always equal to a divided by 1 minus r. What is your a? We know by now that your a is the first term of that specific series or sequence. And your r is going to be your common ratio. So we understand that an infinite geometric series is a geometric series, sorry, that has no last term. Okay, so if that specific series which we have doesn't have a last term, then that's a geometric series which is an infinite geometric series. So e.g., we can have 27 plus 9 plus 3 plus 1 plus, this is a geometric series which is not having a last term. Okay, now in this instance, now we can now apply the sum to infinity, but now we need to understand that this is a proper NP, that an infinite geometric series converges. When does it converge? It only converges when the value of r is between 1 and -1. Okay, so if this r value, the common ratio, is not between -1 and 1, which means that that series doesn't converge, it diverges. Okay, so if it doesn't be the common ratio which you have calculated is not between -1 and 1, which means that specific series doesn't converge, it diverges. So we can now say that, okay, when we want to calculate, or when the series converges, now we can now be able to calculate the sum to infinity using this equation which is here. Only way you can calculate the sum to infinity is when that series, or that geometric series, converges. And in order for it to be able to converge, it needs to be between -1 and 1. Okay, so now let's make a typical example on how we can be able to calculate, or this convergence, and the calculating the sum of all the terms which are into infinity in an infinity geometric series. Okay, now let's make a typical example. E.g., let's say that, consider the infinite geometric series, which is 16 plus 8 plus 4 plus, okay, now 1.1, maybe I can just say, does the series converge? Then now you have to justify your answer. Justify it, your answer. Don't just say converge, justify it. Okay, 1.2. Now you can now also calculate the sum to infinity if it exists. Why did we say if it exists? Because we need to make sure that this specific series converges. If it doesn't converge, then we can't say, and we can't calculate the sum to infinity. So the solution is just also easy. The first thing is to calculate the value of r. Okay, so we are given this series, which is 16 plus 8 plus 4 plus, then we can now calculate your r. Our r is always equal to t2 divided by t1, so that will be 8 divided by 16, which is equal to 1 over 2. So we can see that this r is between 1 and -1, which means this series, they definitely, it converges. Definitely it converges. Now on 1.2, they say now calculate the sum to infinity. Sum to infinity is always equal to a over 1 minus r. What is your a? Your a is your first term. In this instance, it was 16 divided by 1 minus your 1 over 2. Then you use your calculator over there. Then you can get your answer. Then definitely that can be 32. Simple stuff. Those are the few marks which you can claim in the exam. But there's this example which they want to bring in the exams, that, okay, consider this series. Let's check this series now. They just want to confuse you guys, but don't worry, I got you. 16k plus 8k squared plus 4k to the power 3. Then after that, they'll say that, okay, now find the values of k for which the series converge. Okay. And also now calculate the sum to infinity. Easy stuff, okay? Now, how do we do that? How can we solve this question? Again, the same method is used. What are we given? We are given solution. We are given that 16k plus 8k squared. Oh, they say that calculate the sum to infinity. Yes, 8k squared plus 4k cubed. Okay, how can we do that? We know that our r is supposed to be between -1 and 1. So let's calculate r is equal to t2 divided by t1. So that would be 8k squared divided by 16k. Then that would be 1 over 2, because yes, then that would be 1 over 2k. So now -1 less than 1 over 2k less than 1. Now we need to solve for k. Ne? We divide both sides by 1 over 2. Divide both sides by 1 over 2 over there. 1 over 2. Then now we have -2 less than k less than 2, which means that for this convergence we can see that the k values is between -2 and 2. This is simple, straightforward. Now they can say that calculate the sum to infinity maybe if k is equal to 1 over 2. So this is easy already, because we know that you need to have our sum to infinity, which is equal to a over 1 minus r. What's your r? Your r is always equal to t2 minus t1, and we are already given that k value must be 1,5, and our t2 was 1 over 2k, 1 over 2k, and on the position of k now we just substitute with that 1 over 2. Then we now have 1 over 4. So that will now give us 16 times our 1 over 2 divided by 1 minus 1 over 4, because we know that we are given a term to be a was equal to 16k and our k is 1,5, so we substitute there. Then again our r was equal to 1 over 2k. Then again on the position of k we substitute the value of k. Easy stuff. Then you get your answer. Dango means thank you.